Hi everyone! Welcome to the Hamilton tutorial series. In the previous video, we defined the data flow. As you can see on your screen, there are a few functions that define nodes and then define a data flow or a directed acyclic graph, as displayed on the right. But we haven't executed any code yet. That's what we'll do in this video. We'll learn about the Hamilton driver, one of the main objects in Hamilton. It is responsible for assembling the data flow, visualizing it, executing it, and it is also where you'll be adding plugins or ways to load and save data. So we'll start small and we'll build around it throughout this tutorial series. So let's go to the code. This is, again, the data flow definition. It is stored in a file called dataflow.py. It is also called a Python module. It contains the entire definition of our data flow. In Hamilton, one of the core design decisions is separating the definition of the data flow from its execution context. This is great because it allows you to define the data flow once and use it in different contexts. What I mean by that, it could run in a Airflow orchestrated pipeline. It could run inside a web service behind Flask or Fast API. It could be executed as a script or even in a notebook. So in this case, we'll define the driver code or where the driver is instantiated. The expression driver code is used a lot in our documentation. So we'll define the driver code in a script called run.py. To begin, we'll import from Hamilton the driver module. This is not a driver object, this is just the module from Hamilton. Then we'll create a driver called dr. To create the driver, we need a builder. And we also need the data flow definition. So the data flow definition is stored in Dataflow. To pass it to the builder, we will use with modules. And as you can see, there are many with clauses for the builder. And we'll learn about most of them in later videos. So with modules, Dataflow. So currently this object is a builder, but once you call build on it, it is now a driver object. Now, like I said before, we can use this. There's many methods on it, but one of the main thing you want to do when you build your data flow and your driver is visualize it. So we'll call this mydataflow.png, and I just go to my terminal with Ctrl J, and I'll go to the directory of to execute a data flow, and I'll run python run.py. It will produce a PNG, and this is exactly the same thing as displayed here. Actually, behind the VS Code extension is a mechanism that automatically builds the driver and visualizes it for you. So these two match. Now, if we go here and we want to now execute code. So far, we haven't computed anything. We haven't computed any of these functions. We've only built the data flow. So we will use the driver.execute method, and we'll need to give it names of variables we want computed. So we can call prediction targets, and we will get results from them. Results is a dictionary. So if I was to print results keys, and if I was to print results prediction targets. If I execute it again, you'll see that we have the column and we see that it was indeed a dictionary. Hamilton is considered a declarative framework. It uses a declarative approach. And what we mean by that is that you are defining assets or nodes or functions that represent things that you want computed. But when you want them to be computed, you don't actually need to specify how. The driver will figure out which nodes needs to be computed in order to give you back the results you requested. And you can also visualize that. So if I was to say dr.visualize execution, and I said, again, prediction targets, I need to give it an output path, and I will call this execution.png. This will produce another visualization where the requested nodes are highlighted. So again, coming back to my terminal, and we now have, oh, there was a typo in the file name, and you see the outputs requested. The other thing is you can request more than one thing, obviously. This is a list of string. We could also request Titanic data, and we will add this to the visualization, and I'll fix the file name. So this was the incorrect one. And now we see that those are the requested outputs. This is the basics of executing a data flow. In the next videos, we'll detail different tips and tricks to become more efficient in your development. And I look forward to share that with you. See you in the next one. Ciao.